Hello everyone, welcome back to my Chem Corner. So in today's video, we're going to talk about the Intext questions from solid state chapter, which is chapter 1 from class 12. Before we move to the video, if you're new to this channel, please do hit the subscribe button and the bell icon so you receive notifications as and when I upload the video. So without further ado, let's start solving the questions of Intext questions. Next is question number 1.6. The question says solid A is very hard electrical insulator in solid as well as in molten state and melts at extremely high temperature. What type of a solid is it? So here the question clearly gives you properties of a particular type of a solid. We need to identify from that what is the nature of the type of the solid that we are having. So here the properties say it is very hard. We all know solids are hard in nature. For a few exception cases where solids are soft. The next property says electrical insulator. Now what's the meaning of an electrical insulator? Electrical insulator meaning it is not going to conduct electricity at all. Insulator meaning a property where it doesn't conduct electricity. Like for example, if you take your cellophane tape. You tie the wires with the cellophane tape, it is not going to help and conduct electricity. So there are certain electrical metals which are electrical insulators, which means they don't conduct electricity in solid phase, as well as if you're trying to melt them, molten state also, where even at very high temperature it is not going to conduct any electricity. So these are a few properties given to us. From that we need to identify. So if you look at the table where we learnt about molecular solid, ionic solid, covalent solid, metallic solid, we all know the properties that are coming from there. Now when you're talking about, say for example, metals which are they are very hard. Now if you see from that metallic solids, most of them are softer ones. So metallic solid is completely out because under metallic solid there are a few which are soft. Then when you look at ionic solids are hard but they are brittle. But the conductivity characteristic feature says that it will conduct electricity in the molten state. So ionic solids are also not an option. You are left out with metallic solid, but metallic solids, they say they are conductors in solid state as well as in the molten state. So it is definitely not going to be a metallic solid. So the only option that you are left with is covalent solid. So here for this type of question given to us, the type of solid here is a covalent solid. So out of these four, the answer is covalent solid. So we need to understand the properties. Only then you'll be able to actually tell what type of a solid is for so and so question. Alright, now question number 1.7 reads, ionic solids conduct electricity in molten state but not in the solid state. Explain. So for this, I would like to take an example of sodium chloride, which is the simplest ionic solid that we can talk about. Now we all know, even in lab also, or simple thing, sodium chloride is a salt. If table salt, you can say, if you look at your salt that's there in home, we all know that the nature is crystalline. So if they are crystalline, that means when you try to melt them, it can give you sodium ions and chloride ions. So here in solid state, the sodium atoms and chlorine atoms are tightly held by strong attractive forces in solid state, right? Here, but when they are in the molten state or you try to melt them, these will turn into ions and the ions are free to move and the interattractive forces between them are the least. Why? Because you're trying to move away from each other. Now when that happens, the attractive forces between them will be the least. Therefore, Na plus and Cl minus ions formed will start conducting electricity in the molten state. So it's a very basic type of questioning that is asked in this. So that means it should be easy for you all to answer also. Alright, now question number 1.8 reads, what type of solids are electrical conductors, malleable and ductile? Now in this case also it clearly reads that you have three properties: electrical conductors, which means they are conductors of electricity; malleable and ductile are those properties of metals that can be beaten into sheets or drawn into wires. Alright, so those characteristic feature can be easily given by metallic solid. Alright, so that is the answer for question number 1.8. Now the next one is question number 1.9. It says give the significance of a lattice point. And before we know what is the significance of a lattice point is, try to understand what is a lattice point. Now if you look at a cube, each corners of these cubes have some dots. They are nothing but lattice points. You get the geometry of a cube is when you join those lattice points, you get the entire unit cell. Right? So here lattice points can be atoms, they can be ions, or they can be molecules also. These dots that you see can be atoms, they can be ions, they can be molecules. But in a diagram, how are we trying to represent them? They are represented as a point. When these points are joined together, they are going to form an entire lattice structure or a crystal lattice. Now that is the significance of a lattice point. That's why we need it. If we don't have a lattice point, we cannot study about the BCC or FCC or a simple cube or packing efficiency. Nothing of these can be learned. So lattice point may seem a small thing, but its significance is big. Alright. Now, question number 1.10, it says name the parameters that characterize a unit cell, which means when I take a unit cell, what other different parameters can I take into consideration? This is just a simple example of, say you've met someone new, but for you to talk to them or for you to discuss something with them or approach them, first you need to know basic mentality of that person or a thought process of that person, or at least know who that person is. Same thing here, when you're studying about unit cell, you need to know what are the basic parameters in that particular unit cell. Now, how are you going to come to that conclusion? For that, you can take a simple cube. Now, when you look at that cube, what happens is you have different edge length in this case. Now, a cube necessarily doesn't mean it's going to have the same angle, we have learned 7 different parameters, primitive unit cells in this chapter in the start itself when we learned. So that means to say a unit cell need not be a cubic shape always. It can be hexagonal, it can be monoclinic, it can be rhombohedral, which means the angle can be different, the edges can be different. So here, when you look at a cube, it can have one of these edges which are the smallest, which is given as A, another long edge which is given as B, and the one going vertically upward, which is the height of it, which is the C. So that way we will have 3 edges A, B and C. Now each of this will have a different bond angle depending on how long the edges are. So we will have between B and C, you will have a bond angle which is alpha. Between A and C, you will have a bond angle which is beta. And between A and B, you will also have a bond angle which is gamma. So that way you will have 3 different angles, alpha, beta and gamma. So therefore, we will have 6 parameters when you look at a unit cell. So this way you will be able to identify what are the different types of alpha, beta, gamma or A, B, C in a particular type of a unit cell, which is not necessarily always a cube. We have also learnt about 7 primitive unit cell in the very start of the chapter. Alright.